Okay, this is 5.4 volumes, all about volumes. Um, do we have all of it? 4.2. Let me check. Yeah, I think it's yeah. It's I think it's everything. Because point one is disk method, point two is washer. Anyway, let me start. Uh, Before starting the questions, I kind of want to explain what's happening. Basically, when we say volume of a solid, just so you understand what's happening, this was from the area recording. I just want to check something. Yeah, so this was from the area recording. I told you you can find the area. However, same graph. Let's say now, okay, you have a graph. Oh, okay. Let's say you have a graph. Okay, you can actually look at this from a 3D perspective and see it revolve. And I can't do it on open board, but I did find a website that why is it bugging? Okay, so let me just set this to 0. Okay, so basically, I'm sure you're all familiar with the graph y equals x squared, which is a parabola. At this point, خلاص, everybody should know y equals x squared. You either are taking the sat or have taken the SAT, so you should know what y equals x squared is. Or you took IGCSE math, where you also should know what y equals x squared is. So this is y equals x squared. Basically, this is the x-axis, this is the y-axis, right? So basically, what we're gonna do is we're gonna take this y equals x squared, and I'm gonna say from 0 to 1, okay, I want to rotate it, okay? So I'm gonna start rotating it, and you're gonna start seeing, whoa, you're gonna start seeing a solid form. So I'm rotating it around what? The x-axis. So imagine you took it and you just swung it around the x-axis. So you kind of see over here. You see, you get some sort of cone shape. Okay, sometimes it's a disc, sometimes whatever. But over here, basically how they found the volume of this is they integrated it. Okay, because it's a cone which its radius, or no, it's actually, you could say it's kind of like a sphere that's radius substantially gets larger as you move along the x-axis. And this happens, by the way, this works for any two values. Like, it doesn't have to necessarily be from 0 to 1, and you can put it from 0 to 2, and you can see how big it comes. Zoom out a bit. You can see over here. You get what I mean? So basically, you took this y equals x squared, baramta, or you turned it around the x-axis. Okay, this is how it looks, and it has its formula, of course. I'll show the formula in a second, but the formula is the volume of any revolution is pi integral f of x square dx. Okay, sometimes you may have the volume between revolving. We will get to those questions later on. But for a simple revolution about the x square, this is how it looks. Pi integral f of x square. Okay, let's start. That is what we call the disk method. This is the disk method because it kind of looks like a disk, صح? You guys know what a disk is. It's like a circle. بس هلا اذا رحت جبت لك انه I want to use it, بس I actually I can't. I want to, like, it's not letting me. Wait, let me see. Okay, so I know I said I wouldn't touch on the washer method, but I found a visualization which I will go to in a second. So we're gonna solve the first two questions of the disk method, and then go to the washer method and explain it. The finite region R bounded by the curve y equals f of x 3x minus 2. This is a straight line. The x-axis and the lines x equals 1 and x equals 3 is rotated completely about the x-axis. What is the volume? Again, similarly to the area, you have your bounds, you have your curve, and your axis of rotation. What do you have to do? Volume is equal to pi integral a to b f of x square. Okay, dx. That's it. Yeah, you really don't have to do anything. So it's going to be pi integral 1 to 3, 3x minus 2 squared dx. What's 3x minus 2 squared? A minus b squared is equal to a squared, so 9x squared, minus 2ab, so minus 6x, plus b squared dx. Now, can you integrate this? Of course you can. it's gonna be 9 over 3 x cubed plus minus 6 over 2x squared plus 4x. What are our bounds? 1, 3, right? Let's just simplify it a bit. It's gonna be 3x cubed minus 3x squared plus 4x. Okay. Uh, okay, yeah. Our bounds are 3 and 1. So let's do it. Remember, we have pi outside. So your final answer just should have pi. Okay? Just make sure you have the pi outside if it's written. Okay? If حتى in your final answer, make sure to include pi. So you're going to have 3 times 3 cubed minus 3 times 3 square plus 4 times 3 minus open bracket 3 times 1 minus 3 times 1 plus 4 times 1. Okay, close bracket. Okay, I didn't put 1 cube 1 squared because yani, it's kind of obvious. So 3 times 3 cube. I'll just cut. Okay. Okay, I got 62. Basically, I'm stupid. I don't know how to multiply two numbers. Ya Allah. Ya Allah. Okay, so I made the mistake in expanding 2ab, right? 2ab, so 2 times 3 times 2, which is 12. So it should be 12, 12, 6, 6, 6. Okay, so let's fix this over here. 6. Hon command 6. You get 38. So equals 38. So easy, very easy, this method. Second question should also be nice and simple. The finite region bounded by 2 over x, the x-axis, x equals 2, x equals 4, is rotated completely. Find the volume. Again, volumes equal integral a to b, f of x squared. So a pi, pi times integral a to b, f of x squared. Just in case it comes, these are both correct. Okay? Because apparently people they were asked in previous years which of the following represents the volume of the solid. Okay, these are both correct. Pi can be outside, pi can be inside. It doesn't matter. You guys know integral of a f of x dx is the same as doing a integral f of x dx. It's the same thing because it's a constant being multiplied. So you can take the constant out. عادي. It's fine. Okay. Anyway, where was I? Yeah, anyway, in case they ask, these are both correct. They were two correct answers. It was a multiple choice question. Okay, it came in a previous year. I was looking at one of the past exams. Okay, anyway, so your volume is going to be pi integral from 2 to 4 f of x squared, so 2 over x squared dx, right? Type, let's see. Integral, okay, whatever. You're going to have pi integral integral 2 over x. Whoa, what am I doing? Integral 2 to 4. I need square. I forgot square. When you have a fraction squared, you just put the square inside. Okay, so it's going to be 4 over x squared dx. And I'm pretty sure all of you know how to integrate this. You have to take x squared up. Okay, let's continue. It's going to be pi 4 over minus 3x, I'll say 4 over minus 1. 4 over minus 1, x to the power of minus 1, and in between 2 and 4, right? Let's just simplify this. I hate it looking like this, okay? Just for the future, if you ever get this x to the power of minus 1, even though, okay, here it doesn't matter, take it down. Anytime you have a negative exponent, take it down. Although now you're going to be like, man, you're just substituting. What's the problem? You're falling under the same power. There's the same thing. Take it down, okay? Get used to taking it down, because later when we do improper integrals from a to infinity, and you're substituting and you have infinity to the power of negative 2, some people will think it's up, okay? Since remember, like, but so you have x minus 2 and you have to substitute infinity as x. So what they would do is they put infinity minus 2 over 1 and they'd get it wrong because the infinity should be down and you're supposed to get 1 over infinity, which is 0. Anyway, that's for later. That's for 5.5. Okay, I'm not going to have ahead of myself, but for that reason, get used to putting the x down. I'm telling you this because I make that same mistake. It's normal. Okay, please keep your negative exponents down. Anyway, you have pi outside, 4 and 2. We're going to start with 4, so it's going to be minus 4 over 4. Minus, open bracket, minus 4 over 2. Okay, so you're gonna get minus 1 plus 2, which should be Whoa. Whoa, 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 whoa. We did something wrong. We did something wrong. Unless I just don't know how to add. لا لا, there's definitely something wrong. كيف طلع over 3 minus 4. Hold up, let me check. No, Bella, I'm correct, but they did. Oh my god. Okay, the answer I got is 1. And I'll do it on calculator. I'll show you. You can do this stuff in your head. Minus 4 over 4 is minus 1, minus 2, which is just 1. But we can do it. Minus 4 divided by 4, minus 4 divided by 2. You get 1. Okay. 1 pi, right? What are they saying? They're saying k over 3 pi. This is the stupidest shit I've seen in my 10 years of being in the Sabbath system. I've never seen a question this stupid and this ought to trick you. Okay, why are they putting k over 3? Okay, 3. What's the point? I don't understand it. Okay, 3 over 3. Bro, just say 1. Just say k pi. K is 1. I don't know why they're saying k over 3, 3 and then k is 3. Because 3 over 3, I'm sure you all know is. Are you trying to trick students? مش فاهم. It's bullshit in my opinion. Okay, so 1 pi, if they were to put it over 3, oh my god, multiply by 3 up and down, you're gonna get 3 over 3 pi. It's so stupid. I doubt you're gonna see a question like this in the exam. I hope يعني ما بيتفلسفوا and get it for you. Okay, question 3. Okay, هلا we're starting with the washer method. 1, 2, 3. Then what's this? This is this looks like a nice question. I feel like this could come in written, but I haven't really seen tops yet. We have tops 30, 32 to 41. Ha, damn, that's way too much. Wallah. Hold on. 32 to 41. Well, over here 1. Oh shit, that's a lot of tops, bro. Oh. If this doesn't come in your periodic, it's gonna come in your final. Okay, it's either this or this. They're kind of obvious. Oh, they all look like they can come. Wallah. That's way too. Waha. Damn. Okay. Anyway, let me chop. What's this? Okay, this comes. By the way, this is gonna come in your exam, 100%. I'm telling you from now. Okay. 3. Let's see. The region bounded by the curve. Okay. Washer method. This is the washer method. I'm gonna use a website just so you can show it. So نحن till now my neck hurts, man. Till now we explored rotating a graph or a curve. Let's say and I drew a line. So I'm gonna not only rotate the curve, I'm gonna rotate the shaded area around the x. So what's gonna happen is you're gonna get a solid, but that solid actually has a gap. It kind of looks like a washer. So let me show you. Not a washing machine. Something like this is a washer. I'm sure many people know what this is. Basically, a washer is a solid with this gap in the middle. Okay, so this is called the washer method for that reason. Because when you take, let's say, مثلا, I'm gonna use square root of x and x minus 1. Or no. Let's see, x.
What?
2x. 0.5x. Okay, so let's say you have two graphs. Okay, square root of x and 0.5x. These are random numbers. I don't care. Let's say I wanted to rotate the shaded area between them around the x-axis. Okay, so I want to rotate it around the x-axis, which is y equals 0. Okay, let's start the rotation. You see it's starting to rotate. You can kind of see the shape beginning to form. Let me actually, you know what? These are too close to each other. Let me use a different graph. Hold up. Okay, so I just changed the line to y equals x. It doesn't matter. I'm just playing around with these values. And basically, you can kind of start seeing the solid that's beginning to develop. As you can see, it's rotating and rotating and rotating. I don't know why this website doesn't give me like the previous website that I used for the first volume. I don't know why it doesn't just give me a complete graph. But basically, you have to wait a bit until the simulation is done. Yeah, so I think you can kind of see what I'm talking about. Let me pause this. You can see I have a solid. This is stop. Okay, no, stop. What? Whoa. Okay, so I have a solid. It's this one big circle. Okay, and imagine this continues. I don't know why it stopped. And inside you have a small circle, and this small circle here is the empty space that we don't care about. Okay, so basically, when our mathematicians came and they were like, okay, we need the formula for this, they decided to make this is the formula. Okay, hold up. This is two circles, right? So they were like, damn, let's see. This is the volume I want is the bigger volume, which is pi r squared, right? Let's call it big R, right? Because it has the bigger R. And then minus the inner volume, which is also pi r squared. So they were like, damn, you know what? Let's see. The outer volume, we know it's equal to pi integral a to b f of x squared. So they're like, okay, cancel pi. Okay, let's cancel pi. Let's keep that to the side. We're just going to put pi to the side. Okay. And then they were like, damn, this f of x squared should be equal to r squared minus r squared. Okay. So they're like, instead of f of x squared, you know what? Let's put r squared minus r squared. Okay. This is by the way how formulas are derived, like actually in the real world. Okay. So from a to b, r squared minus r squared. Just like that, we just derived the formula. ما بدها شيء, ما بدها شيء. Okay. So they took the pi to the side and they're like, damn. Okay. It's the same thing, but instead of f of x squared, we're gonna change it to r squared minus r squared. Okay, so this is the formula for the washer method. Okay, extremely easy, but the function is just r squared minus r squared. R, capital R being the bigger radius, the outer radius, and small r being the smaller inner radius. Okay, when you see this type of question, you're going to be like, Walid, how do I know which one's bigger radius, which one's smaller radius? Let's turn off our rotation over here and go back to our original graph over here. I was using square root of x and x minus 1. Okay, so no. X. So if you zoom in, if you're revolving about the x-axis, and this is the easiest way for me to do it, I just draw a circle like this. Okay, I just think of it like this. When we're talking about the x-axis, which one's going to be the bigger radius? I just draw a line up. Okay, which one's going to be the bigger radius? The top function. So always the higher function is going to be your bigger radius. Our bigger function is what? Square root of x, okay, which is root x. Okay, so in this case, our r is going to be root x. Our smaller radius is going to be what? The second function, which is just y equals x. So x. Okay, so the small r is x. And you can simply do integral from the bounds, which they're either given to you or you find them. How do you find the bound? You have to equate both functions. Y is equal to y, right? So root x equals x, and you solve this. Okay. Anyway, integral a to b, and then r squared minus r squared, so root x squared minus x squared. And you integrate the x, remember pi outside. Okay? Please don't forget the pi, please. Okay? Haram. Wallah. Okay. Go back. Allah, we're gonna use the washer method. For the washer method, I always recommend graphing. I always recommend it. Yani it makes your life way easier. Way easier. Okay? If you're saying يا اخي وليد man شو graph مين فاضي, you know who مين فاضي يعمل graph periodic. Let me show you, man. It's so easy والله. You have your graph, you have y equals 2, y equals 2 صح? And then minus x squared plus 3. But والله ما بدها لا. Take your calculator, go to your mode. Every calculator has a stable mode. Okay, type in minus x squared plus 3. No matter what calculator you have, this is, oh, why does I have g of x? But anyway, why 1? Start from, let's say, I don't know, let's go from minus 3 to 3. I hope it works. Okay, so at x equals minus 3, you have minus 6 over here. At x equals minus 2, you have minus 1 over here. And then let's go down. At 0 should be 0. 0 should be 3. Okay, here. It should up here. Okay, then it should be symmetrical because it's a parabola. 1, 2, 2 minus 1. Okay, so we have a point here on 2, and then you have a point here at minus 1. So شوف محلها. Huh? You have it. easily, you can see it took me what, 2 minutes? 2 minutes, but you're gonna guarantee the question being correct. Okay, so basically, whenever you're asked for a volume and there's two curves, two graphs, that means you're using the washer method. But someone will come and tell me حيجي يتذاكى هيقول لي طب وليد, here you used in all of these questions you used two graphs, x equals to x equals 4. طب خي, I'm looking at the x axis and the vertical line, يعني أكيد that's gonna be my bound. Okay, but question 3 and I'm revolving about the x axis, but they gave me a y equals, that's another curve, it's not a bound. Okay, so this is extremely important what I did now, the graphing part, for knowing which one's big R, which one's small r. Okay, so you have 2 over here, you graph y equals 2, then you put into your calculator. As سريع, it takes you maybe 5 seconds, 20 seconds. You put it into your calculator, you have 0, 3, so you have a point here, you have 1, 2, so you have a point here. Okay, oh, hey, I don't even want a detailed graph. Well, I don't even want a detailed graph. I just want to see when is it equal to 2? Like, does it go above 2? Because if it goes above 2, that means this is the bigger radius. Do you understand what I'm trying to say? And the smaller radius will just be this, right? So we have big R, which is this one, and this is the smaller radius. Okay, so you're going to tell me, Walid, big R is going to be what? Minus x squared plus 3. Small r is going to be what? 2. Very easy. Now you can just apply the formula. But I forgot about one part. We need to know our bounds. Remember, volume is equal to pi integral a to b, in this case r squared minus r squared dx, right? But the problem is I don't have my a, I don't have my b. I need the bounds. How do you find the bounds? Always, when you have two curves, you just equate them to each other. Okay, and this is extremely easy to solve. So it's going to be minus x squared plus 1 equals 0. طير هاي لهون بتصير x squared equals 1, x is equal to plus minus 1, right? So it's gonna be, volume is gonna be equal to pi. Our bounds are what? Minus 1 it intersects, and at 1 it intersects. Oh, by the way, you got these from the calculator. It's, when is it equal to 2? At minus 1 and 1. So yani, these are, everything connects, everything is connected to each other. So minus 1, 1, r squared minus r squared, so minus x squared plus 3 squared minus 2 squared dx. So you're going to continue now. V is equal to pi, integral from minus 1 to 1. A squared, okay. Listen, for this one, minus x squared plus 3, you're going to use the rule a minus b squared. Even though people will be like, no, Walid, it's minus a plus b. Why are you using this? Man, ya Allah. Okay. If you have a negative at the start, it's the same as saying 3 minus x squared. Okay? بس ما تتذكى. Don't act smart. Okay? A plus, it's gonna be, you're gonna use a minus b to the power of 2. You're gonna use that rule. So it's gonna be a squared, so it's gonna be x to the power of 4 minus 2ab, so minus 2 times 3 times x squared plus b squared, so plus 9 minus 4 dx. Why minus 4? Because this is 2 squared over, okay? Continue. V is equal to pi integral minus 1 to 1 x to the power 4 minus 6x squared. 9 minus 4 is plus 5 dx. Integrate, it's going to be what? X to the power 5 over 5 minus 6 over 3 x cubed plus 5x dx. Okay, true dx. In between the bounds, minus 1, 1. Let's continue. Let's start substituting. I'm going to replace the 6 over 3 with 2. Okay, so minus 2 x cubed. Let's start. X to the power 5 over 5. So 1 to the power of 5 over 5 minus 1. So, minus, 2 times 1 to the power of 3 plus 5 times 1. Minus, open bracket, substitute minus 1. Minus 1 to the power of 5 over 5 minus 2 times minus 1 to the power of 3 plus 5 times minus 1, close bracket. Yalla. Mode 1. 1 over 5, because 1 to the power of anything is 1, right? So we can easily do this, open bracket, minus 1 over 5. Minus 2 times minus 1 plus 5. Minus 18. Oh, shit. Why is it? Ya Allah. What did I do wrong, man? I'm sorry, I don't know why I put plus 5 by accident. 5 times minus 1 is minus 5. Yeah, so it should be 32 over 5. Sorry. So, to summarize, how do you solve a washer method question? How do you know you're solving a Washer method question? You know you're solving a Washer method question when you see two curves. Okay. How do you're gonna say, Tawali, how know if this how do I know if the second one's a curve? You know the second one's a curve if you're talking about the x-axis and they gave you another y equals. Okay. Or they tell you another curve. Or they say the word curve. Okay. Okay, and then you're gonna be like, Walid, how do I know which ones are which one's big R? Because like I need to use the formula, right? Before using the formula, actually, it would have been a good idea for me to find the bounds before using I don't know, before drawing and whatever. So always find your bounds, -1 and 1, and yani it's you need to know which one is big R and which one's small R. It can be done يعني on a pen and paper. You can try points. Okay, you can like مثلا I didn't even have to graph, by the way. I can just look table mode, put in -x squared plus 3, حط table mode, forget about g of x. Okay, if you have g of x, just put 1. Okay, start obviously with a negative number, end with a positive number, whatever step is always 1, and look for like y equals 2 is always at 2. Look, does it ever go above 2? Yes. Okay, it does go above 2. So for that reason, without even drawing, you can determine that it's your bigger R. Okay. Lucky if you know that's your bigger R, then خلاص, you know the other one's a small r. Or now everything else is just application of a formula and integration and substitution, or so on and so forth. I'm taking my time on these questions because they're course practice. Course practice, you guys are going to rewatch these for finals. Future grades, inshallah, will watch them as well if my competitors uh, decide to like actually not post the stuff I already have posted. But I'm explaining in detail because these concepts need to be understood and not memorized. I don't like teaching you memorizing. Math isn't memorization. It really isn't. You can understand it. Anyway, the region, another question. The region bounded by the curve y is equal to x squared plus 1 and the line y equals 5 is rotated completely about the line y equals 1. The volume of the generated solid is k over 5 pi cubic units. What's the value of k? We're rotating about the line y equals 1. This is where stuff starts to get like, Okay, so I was a bit unsure of this, so I went and checked it. I just wasn't sure. Same thing, Washer method. You have two curves, line y equals 5. You have two lines, whatever. Curve, line, whatever. You have more than one curve. You have another line. A line counts as a curve, by the way. But except this time, you're rotating completely about the line equals 1. Some people, they're gonna go like, طب didn't you say, it's another curve when they tell you, مثلا, this is you're rotating about the x-axis, but this is a line with y equals. Okay, yeah, sure, but come on, it's kind of obvious you have more than one curve. They're telling you this is a curve, this is a line. You're rotating both of them. You're rotating both of these about y equals 1. Okay? Here's what you do. Because you guys don't like to graph, I'm gonna graph first, explain what I did, and then at the end of the explanation, I'm gonna tell you how you can do it maybe without graphing. But again, I always suggest you to graph, okay? You have x squared plus 1, which looks like this. And if you don't know how, put it in your calculator. Mode 7, x squared plus 1. وحطها نبلشها -3. Sorry, g of x always set it as 1. We don't care about g of x. -3, 3. حطها step 1. Okay, so -3 it's at 10. We don't really care about this. -2 it's at 5. So -2 it's at 5. And then at -1 it should be at 3. I know 2. Oh yeah, 2. Okay. And then it should be the same thing over here. I'll scroll down a bit and show you in a sec. Okay, so it kind of looks like this. It's a parabola, obviously, because it's a quadratic. C1, 2, 5, whatever. Okay. Why I'm taking -2 to 2? Again, I should have found the bounds the first thing. Always find the bounds as the first thing, just so you know what points to ignore. It makes your life easier. So you're gonna get x squared equals 4, so x is equal to plus minus root 4, which is plus -2. Okay, so -2 and 2. This is your bounds. خلاص عرفت انت you're looking at -2 2. y equals 5 يعني ما في أسهل من هيك. The graph y equals 5 looks هيك. So we're looking at the intersection points. When they intersect, right, in between the bounds, in between the intersection points, we're going to see now which one's the bigger r, which one's the smaller r. People are going to say, okay, y equals 5 is the bigger r, so big R is equal to 5. And x squared plus 1 is obviously the smaller r. No matter where you go, y equals 5 is higher than it, other than here, of course. But when they're the same height, we don't care about when they're at the intersection points. Other than intersection points, in between them, who's higher? Y equals 5. And so the smaller radius would be x squared plus 1. This is what people will say. They're going to completely ignore the fact about y equals 1 because they're jumping quickly. They want to solve. They're very excited to solve and plug in numbers. This is where you're going to make a mistake because we're saying you're rotating it about y equals 1. In the previous questions, we said about the x-axis. If you don't know, the x-axis is y equals 0. It's this, right? When y equals 0. Over here, it's y equals 1. What's the difference? You went up a bit. So we're rotating it about this green line that I'm going to draw in a sec. So for the radius, I actually have to find the distance between y equals 1 and the curve. Okay? So let's see. This whole distance used to be 5. It used to be 5. Obviously, big R is 5, right? So it was the y equals 5. It used to be 5, but since now I'm starting already at 1, how much am I removing? I'm removing 1. How about for the small radius? The small radius used to be what? It used to be x squared plus 1, right? It used to be x squared plus 1. But since I'm starting at 1, how much do you remove? 1. Okay? So that means your big R is 4 and your small r is x squared. Okay? So in conclusion, what does this mean? When you're rotating about a line, a horizontal line, big R and small r are equal to, let's say, r prime, big R prime and small r prime, the new values of them, is just equal to old r minus the function, let's just call it h of x. Okay? So small r minus h of x. Okay? I hope this makes sense. Let's continue now. We know our big R, we know our small r, we know our bounds. Very easy. V is equal to pi, integral from the bounds minus 2, 2. Big R minus small r, so 4 squared. Remember, it's r squared minus r squared. My math teacher, for some reason, every time he solved this week, or this on Wednesday, every question he solved, he forgot to put square. So 4 squared minus small r squared. So x squared squared dx. Okay, so v is going to be equal to pi integral minus 2, 2, 16 minus x to the power 4 dx. Please don't be like my math teacher and don't forget to put the squares. Okay, continue. Let's integrate this now. It's going to be pi integral 16 minus x to the power 4, 16x minus x to the power 5 over 5. Our bounds are minus 2 and 2. Let's continue. So it's going to be pi 32 شو 30 16 times 2 is 32, but I don't know why I'm getting ahead of myself. 16 times 2 minus 2 to the power 5 over 5 minus open brackets 16 minus 2 minus 2 to the power 5 over 5 and close the bracket. Do it on your calculator. I'll cut to the part where I have it done on my calculator. Over here we got 256 over 5 pi, of course. Please don't forget the pi. You know, the pi is still there. ما راحت ما هربت. 256 over pi. So k is equal to 256. Okay. Question 5. Okay. في كتير حكي man. Consider the region R bounded by the curves y is equal to x squared and y is equal to root x. The lines x equals 0 and x equals 2. If R is rotated completely about the x-axis, then the volume of the generated solid is k pi cubic units. So we want to rotate about the x-axis, and they were kind to us. They gave us the bounds. They gave us أعطونا كل شيء. Very nice, wallah. So all you have to do is just equate. Use the formula pi integral 0 to 2 r squared minus r squared. Well, the only thing you might have to find is which ones are which ones small r, right? X squared and root x. If you want, actually, I think for the non-integral calculators, it doesn't have the f of x, g of x function, but I want to test something out. If I put root x here, does it give me the actual values? Root 4. Yes, it does. Okay, that's perfect. So we're looking from 0 to 2, so I should have started at 0. I start at 0 and at 2. Let's see. So at 0, it's at 0. So for the most part, if you want to graph this, So 0, 0, 1, 1. They both have these points. But at 2 it's at 1.4, so at 2 it starts to curve, so it's kind of like here, but y equals x squared is over here. So y equals x squared goes like this, but root x goes like this. Okay, so we're looking at this point, this part here where they intersect, this intersection point. Okay, y equals root x. If you graph it, at 1 it equals 1, at 0 it equals 0, at 2 it equals 1.4, so it's over here. And if you want to be precise, at 0 0.5, let's see, it equals 0 0.7, so it's over here. Okay, please use 0 0.7 as your step. They're looking at the volume between x equals 0 and x equals 2, so this shaded region over here, right? Draw x equals 2, so we need all of this. Okay, if you realized, and I don't know if you can tell, but we have two separate cases, because over here root x is higher, but over here x squared is higher. So can I do this all in one integral? No, you can't. This is why, again, I tell you again and again, please get used to having to graph. If you don't graph, I don't think you're gonna get these questions correct. Okay, even though they're possible to get correct without graphing, and I'm not saying you won't, but it will make your life way easier. Even though you might think it's harder, but it's gonna make your life easier. So we're gonna split this up into two integrals. Okay, we're gonna do 0 to 1 and then 1 to 2. From 0 to 1, let's call this r01 and small r01. What's the bigger radius? Here, root x is above. If you want my advice, like I told you, use the step as 0.5 in the calculator. So you know, in between the 0 and 1, which one's higher? You know what I mean? Okay, so r01, the bigger radius is going to be root x, or the small radius in between 0 and 1 is going to be x squared. So let's do this. We're going to do volume is equal to pi integral from 0 to 1. Integral from 0 to 1. The function r squared, remember we're doing r squared minus r squared, integral r squared, pi integral r squared minus r squared. So root x squared minus x squared squared dx. So it's going to be equal to, v is equal to pi, I'm going to go a bit faster, 0 to 1 x minus x4 dx, and integrate this, you're going to get pi, fuck, I forgot to integrate, x squared over 2 minus x to the power 5 over 5. It in between our bounds 0 and 1. Let's compute this. It's going to be pi 1 squared over 82. Okay, 1 squared over 2 minus 1 to the power 5 over 5 minus 0. Right? So you're going to get 1 over 2 minus 1 over 5. Let's just do this on our calculator. 1 over 2 minus 1 over 5. You get 3 over 10. Okay, so this is our first volume. We're going to add it now to the second volume. The second volume, the bigger radius is now x squared. So from the r, for now from 1 to 2, is actually x squared. And the small r from 1 to 2 is actually root x. So let's update our formula now. It's going to be pi. Our bounds are from 1 to 2. Integral r squared minus r squared, so x squared squared. So let's just put x power 4 minus x. I'm just saving us a bit of time. I did the squaring part already. Okay, r squared minus r squared. Okay, so integrate this, you're gonna get same thing as before. Pi, open brackets, gonna be x5 over 5 minus x2 over 2. In between bounds 1 and 2. Now substitute, it's gonna be pi 2 5 over 5 minus 2 2 over 2. Minus open bracket 1 over 5 minus 1 over 2. Okay, so you're gonna get 32 over 5, because 2 to the power 5 is 32, minus 4 over 2, because 2 to the power 2 is 4, minus 1 over 5 minus 1 over 2. Okay, you're gonna get 47 over 10, and we're gonna add our old volume, so plus 3 over 10. So in total you get 5. I'm very sorry for making the mistake at the start, but I didn't expect this to be the question like that. I should have paid more attention to it. Anyway, okay, so for part B, I got the wrong answer 5 times. I'm so high, it's crazy. But you need to reuse the graph we used in part A. I don't even remember if I used the graph in part A. That's took me so long to figure out how to do part B. Anyway, so the graph, I'm pretty sure, yeah, I used the graph in part A. It looked like this, okay? And there are some key points over here. Remember, at 2, root x would be 1.4, but x squared would be 4. So it would look like this. And then you'd have this. Okay. Where our boundaries are x equals 0 and x equals 2. So for the x-axis, we split it up into 3 major points. When I'm splitting the integral up, the main reason for me splitting it up is because the radius is changing. Okay, so we said here we split it up because from 0 to 1, y equals root x was big R, and x squared was small r. And then from 1 to 2, x squared was big R, but root x was small r. Here, for root y, for y-axis, the whole story changes. You're looking at the same concept of radius, but instead of looking from the x-axis, I'm now looking from the y-axis. So you go to y. You're gonna keep on going. Okay, here, which one's further from y? That's the bigger radius. So here, this function over here, x squared, is the big R. So the big R is x squared. But for 1 to 1, from 0 until 1, right? So from 0 until 1. And then the small r obviously will be root x from 0 to 1. Okay, after 0 to 1, let's continue. The bigger r, the one that's further away. Always for the y-axis, if you want an easy way to know which one's big, which one's small, always the big R is the one that's further away from the y-axis. So the one that's further away is obviously the one that's under. It's the opposite for y-axis. The one up is actually small r. The one down is big R. So here it's going to be root x, root x, root x. But because you're going up the y-axis, right? This is the part every student gets tricked about. And you're going up the y-axis, not to the left, to the right. No, you're going up. So you keep on going until over here we hit a point where above that there's no more curve here. So what do we do? So actually, before we reach that point, we started over here at 1, right? Until we reach this point. What's this point? This is radical 2. Okay. Why is it radical 2? Because we're looking at root x, right? So at 2, the value of y is root 2. So here we stopped at root 2. So big R between 1 and root. The calculator value for one in table mode is going to give you the value of 1.411 whatever. Okay, don't use that. Use root 2. Okay, because they're asking you to keep it in terms of root 2. So big R, the one that's further away, the one the one that's below in this period from 1 to root 2 is the graph of root x. And obviously the small r would be x squared, right? The one that's closer to y, small r, x squared. Okay, طب نحنا we stopped here. But what about all this leftover stuff that's up there? We have to account for that as well. But here's the thing. People are gonna get confused. They're gonna be like, okay, so what method do I use here? I don't have two curves. Except you do have two curves. This is your first curve, x squared. And the second curve we're talking about is x equal 2. This counts as a curve as well. Okay? So the big R over here is gonna be 2. The small r will be x squared. You're gonna say, whoa, why? Why is this big R? Because it's further away from the y-axis, the one that's further. Okay, so this is gonna be big R. The small r is the one closer to the y-axis, x squared. So this is from root 2 until 4. Why till 4? Where do we finish? And remember, you keep on going up the y-axis and drawing radius. Okay, where do we finish? Over here at y equals 4. How do you know it's y equals 4? Because at 2, how much is the y value? Y is equal to x squared, so 2 squared, which is 4. So we finish over here at 4. It would be a good idea to match everything. Okay, so مثلا you have 0, you start at 0, your first intersection is at 1, and your second intersection, we finish at 2, right? Our bounds are 0 and 2, we have an intersection at 1, right? Okay, it would be a good idea to find the y values at all of these. Like at 0, it's 0, at 1, it's 1. At 2, the first function root 2 has the value root 2. as a root x has a value of root 2, but the function y equal x squared has 4. So this is why we actually had to split it up a third time, okay? Because of this, because there's more than one. You get what I mean? Because if we were talking about x, we can split it up into this and this, this and this. But y, you always have to split up into this and this, this and this, this and this. But here's the thing, between the last two, there's gonna be a new curve we're talking about. Okay, it's now enclosed by y equals x squared and x equals 2. So now that you know all this, you can solve. Okay, the first thing you have to do when you're solving in the y-axis is change your equation in terms of y. It has to be in terms of y. So x squared, we know it's these all equal y, right? You have to change them and put instead of them in terms of y. Okay, so here x squared equals y. How do you get rid of, you have to make x alone. When I say put it in terms of y, and you make x alone. Make x alone, you square root both sides, so it's going to be root x. Here, root x, to get rid of the root, you have to square both sides, so it's going to be y squared. Sure, root x as the root y. Root y. Because you take the square root of both sides, it's going to be root y. You need to put it in terms of y. Okay? Square both sides, you're going to get y squared. Root x, square both sides, you're going to get y squared. So I'm going to just put y squared. Okay? And square root both sides, you're going to get root y. Here, the line was x equals 2. Okay? If you want to write this in terms of y, you just write 2. Okay? That's it. Okay? X is equal to 2. It's already in terms of y. X is already alone. Do you get what I'm trying to say? This line x equals 2, x is already alone. Okay? I remember one time I said if you're revolving about the y-axis and you have an x equals line, then actually that shows you that this is actually another curve. Okay? So it was x equals 2. Remember, if x is alone, that means it's already in terms of y, so there's nothing you have to change. Okay, x squared equals y square root both sides, so it becomes root y. So now I have everything in terms of y. I have all the boundaries. All I have to do is just integrate. Okay, let's start here. Integral r squared minus a small r squared, big R squared minus small r squared. So we start, our boundary is 0 to 1, pi outside, big R squared, so root y squared, which is y, minus, root y squared minus y squared squared. So it's going to become pi integral from 0 to 1 y minus y to the power 4. I should have written dy. Okay, and if we integrate this, it's going to be pi outside y squared over 2 minus y 5 over 5 between 0 and 1. Let's substitute. Okay, it's going to be pi times 1 over 2 minus 1 over 5, and then akid minus 0, which always do it. Substitute 0 and put it in. Okay, do it, always do it. Okay, because sometimes it doesn't get you 0, but here it does. I'm just gonna skip it for the sake of the video, but do it yourself, please. Okay, always, if it's 0, substitute it. Okay, so when you do this, you're gonna get 3 over 10 pi. How about here? We have y squared and root y. Again, integral from now 1 to radical 2. Right? Our big R, sorry, is y squared. So y squared squared minus small r squared, so root y squared. You're gonna get integral from 1 to root 2 y to the power 4 minus y. Okay, and you're gonna get integrate this y to the power 5 over 5 minus y squared over 2. In between your bounds 1 and root 2, if you substitute, you're gonna get root 2 to the power 5. This is where your calculator fucks up. Okay, because if you put root 2 to the power 5 over 5 minus, I'll show you. Okay, let me continue. Root 2 to the power 5 over 5 minus root 2 to the power of 2 over 2. Put this on your calculator and look what you get. Okay, you get the decimal. Minus root 2 to the power of 2, root 2 to the power of 2 over 2. Look, you get the decimal. So this is why when evaluating it, I'll show you. I had to do it a different way because they want it in terms of root 2, so I should have it in terms of root 2. Okay, so over here, let me continue and put the 1, and then I'll show you how to solve it. Okay, So I'll continue down here because I don't really have much space. I'll I'll continue here. Okay, minus open bracket, substitute 1 over 5 minus 1 over 2. Okay, so root 2 to the power 5, since it doesn't work on a calculator, it's the same as saying root 2 to the power 5. And like this, what's this equal to? It's equal to root 2 to the power 4 times 2. And you can take the 2 to the power 4 out, becomes 2 to the power of 2 root 2, which is the same as 4 root 2. This is how I did it, okay? Some people may do it differently. Okay, so 4 root 2 over 5 minus root to the power of 2, which is just 2 over 2, okay? Minus 1 over 5 minus 1 over 2, this is just going to be plus 3 over 10, if you do it on a calculator, okay? Now, if you add this up again, you're gonna get a decimal. So for that reason, let's actually do it, okay? For root 2, we're gonna ignore it, but I'm gonna add it as if I'm adding 4 root 2 over 5. Yeah, I'm gonna add it as if I'm adding, I have to add it myself, sorry. I have to add it myself, okay? 4 root 2 over 5 minus 2 over 2 plus 3 over 10. You actually have to do it. Let's start with the minus 2 over 2 plus 3 over 10. Minus 2 over 2 plus 3 over 10. It's minus 7 over 10. Okay, so I'm going to be left with 4 root 2 over 5 minus 7 over 10. I need to now multiply by 2 up and down, صح? So it's going to be 8 root 2 minus 7 over 10. صح? Okay, so this is your second one. Times pi, of course, huh? Times pi. 3 over 10 pi وهون على كل pi. Okay, now for the second one. I know في كتير كتابة بس I'm sorry. Now you're going from what? From root 2 up until 4, right? And we found our big R, small r. After you find your big R and small r, all you have to do is just do math, man. You just put in numbers. R squared minus R squared. So 2 squared minus root Y squared. So it's going to be integral from root 2 to 4. 4 minus y dy, huh? I'm forgetting to put dy, but you need to put it. Okay, please make sure you put it. Okay, so pi outside, again pi outside. Should have put pi outside. Pi, whatever, pi, close brackets, pi. The pi should be there, okay? It has to be there, or your answer is wrong, okay? So here you're gonna get pi actually integrated 4y minus y squared over 2. And our boundaries are what? From root 2 till 4. Let's do it now. Substitute. So it's gonna be pi open bracket 4 times 4 ما في over 4 times 4 minus 4 squared over 2 minus open bracket root 4 times root 2, so it's just 4 root 2. I don't know why I keep on putting over 4 times y, so 4 times root 2 minus root 2 squared over 2, close. Simplify this. Let's do this 16 minus 8, okay, because this is 16 minus 8. 8 minus, again, if you do the radical 2 on your calculator, it's going to give you a wrong answer. So you actually have to do it by hand. Okay, let's simplify this root 2 squared over 2. Okay, it's 1, right? So it's going to be minus 1. So we can rewrite this as pi 8 minus 4 root 2 minus 1. Why? Because this is 8, this is 4 root 2, this is minus 1. Okay, and remember the minus is outside. Please don't fuck it up. Okay, so you're gonna get 8 minus 4 root 2 plus 1. Remember pi is outside. Okay, because the minus are distributed inside, it becomes plus 1. So you're gonna have pi into 9 minus 4 root 2. Okay, type, you now have all of these. Alright, add them all up. If you add them all up on your calculator, you're gonna get a wrong answer. Okay, so for that reason, we have to add them up by hand. So let's start 8 root 2 minus 7. I'm gonna put pi outside, okay? Over 10 plus 3 over 10 plus 9 minus 4 root 2. Okay? We can add these since they have same denominator. So minus 7 plus 3 بتصير شو minus 4. So 8 root 2 minus 7 plus 3 is minus 4 over 10 plus 9 minus 4 root 2. Okay, we need to multiply up and down by 10. So multiply by 10, multiply by 10. So what's it gonna be? Pi 8 root 2 minus 4 over 10 plus 90 minus 40 root 2, all of this over 10, huh? Yalla. 8 root 2 minus 40 root 2 is minus 32 root 2. But I'm going to start with the positive values first. Minus 4 plus 90 is 86. 8 root 2 minus 40 root 2 is minus 32 root 2 over 10. عندك pi outside. Okay, but what they have it over 5. So we can just divide by 2 up and down. So it's going to be pi 43 minus 16 root 2 over 5. Okay, so what's the value of k? It's gonna be 43. Okay. Question 6. Ya Allah. The diagram below shows a part of the curve 1 plus 4x to the power of half. So this here. Okay, and the point A 2 comma 3 lying on the curve. So this is the point here. The line AB intersects the x-axis at 5 comma 0. So they gave us 5 comma 0. The volume of the solid of revolution obtained when it's rotated through the x-axis. This is so easy. Okay, so easy. Why this is so easy is because you don't need to even use radius. Okay, look, you're rotating about the x-axis. You don't have two curves. Well, they tricked you with the second curve, but basically, انت أول شيء you can't do it all together. Why can't you do it all together? Because look, over here we're talking about the curve 1 plus 4x to the power of 5. But over here, what does it become? It's this new line. I don't know what it is, but I think you have to figure it out. The way I solved, I figured I had to use, I need to figure out what the line was. Anyway, so it switches curves. So for that reason, I'm looking at one curve here. Here I'm looking at one curve. Okay. Let's start with this one here. Okay, how do we find the volume from 0 to 2? It's a normal curve. لا في second curve, so you don't need to use washer method. There's no big radius, small radius. We're just going around the x-axis, so ما في أسهل من هيك. You can just use the disk method that we used earlier, since there's no second curve, it's just one curve. So the volume is just going to be equal to pi integral from 0 to 2. Why am I lagging? From 0 to 2 of the curve 1 plus 4x to the power of half. And remember, it's always f of x squared. So the 2 cancels with the half. So it's just going to be integral 1 plus 4x, which is just going to be x plus 4 over 2 x squared in between our boundary, pi outside, between our boundary 0 2. You guys know it. I just sped up a bit. So it's going to be x plus 2x squared in between 0 and 2. So let's substitute 2. You're going to get 2 plus 2 times 4, because 2 squared is 4, minus, now open brackets, 0. Okay, so you're going to get 10. كيف جبت 8 10 pi. هلا for the triangle. For the triangle, they told you can use this, but I'm gonna prefer not to use it because you're going completely against what we've been using for the past 5 questions. Okay, you now have this other curve. Actually, it would be easier to use this formula. This triangle, right? Oh, this triangle, when you rotate it about the x-axis, you're gonna get a cone. I'm pretty sure you can kind of visualize it. You get this cone over here, and you get it like this. You know what I mean? You get this cone. So you can use this formula actually to find the volume of this. If you want, you'll get 1 over 3 times pi times the radius of the cone from here to here is 3, so times 3 squared, times the height of the cone, which is from here to here, from 2 to 5 is also 3, so you're going to get 9 pi, of course. So 9 pi and 10 pi gets you 19 pi. This is the chill way, okay? But if you want to use the way we've been using the past 1 hour, you need to know what's the equation of this line. Okay, the equation of this line is, you need to know it. It's very easy. Its y-intercept is 5, so it's going to be y equals mx plus 5. It's very easy. Okay, the number b, by the way, is always the y-intercept. When you see y equals mx plus b, this is always the y-intercept. And the slope is -1. you're gonna say, Tabolid, why? How do you know all of this? Without even doing rise over run, it's so easy. Okay? You're going without doing y2 minus y1. You're going down by one block. For every one, you're going down by one. So it's minus one over one. That's the rise over run. I like to do it this way. It's easier. It's faster. So y equals minus x plus 5. If you want to use the formula, volume equals pi integral from 2 to 5 minus x plus 5 squared dx, and then substitute 2 and 5, you should get 9 pi, and then when you add them you also get 19 pi. I'm not going to continue to do it. You know how to integrate and substitute, okay, if you want to use this method. Question 7, there's 2 more questions left, inshallah they're easy. This is the one that always comes, okay. The diagram below shows the graphs of 2 horizontal lines. The function y equals f of x equals kx squared plus m, where k and m are constants. Okay, so this is the function. Over here you have 2 horizontal lines. Point A has coordinates 1 comma 6, point B has coordinates 2 comma 18. And then fill in the blanks. I guess they want you to find k and m, and then they're saying find the volume of the shaded region when it's rotated around the y-axis. First, I'm going to start with finding k and m. It's very, very easy. They gave you a point 1 comma 6 and 2 comma 18. So they gave you 2 points. So by the way, f of x, y equals k. So you have y equals kx squared plus m. Just substitute these 2 points. You're going to get 2 equations and you can solve it easily. Y equals kx squared plus 1 plus m. So we're going to start with just substituting x and y, okay? So the first one, y, 6 is equal to k times 1 squared plus m. The second time you substitute, you're going to get 18 is equal to k times 2 squared plus m. So you're going to get 6 is equal to k plus m. And here you're going to get 18 is equal to 4k plus m. You can easily do a simultaneous equation. You can substitute m, take k to the other side. It's going to be 6 minus k. So that means here you can substitute 18 is equal to 4k plus m. What is m? Plus 6 minus k. Okay, so you're going to get 3k plus 6 is equal to 18. So you're going to get 3k equals 12. So k is equal to 4. And you know m is equal to 6 minus k, so it's going to be now 6 minus 4, which is 2. Okay, so m is 2, k equals 4. Then now find the volume. You now know the equation, so it's going to be 4x squared plus 2. Okay, how do we find the volume between the y-axis? Okay, do you have your intervals? You have your intervals, right? They're from over here, from this point A, 6. Remember, we're talking about y, not x. So not 1, not 2. No, we're talking about 6. And goes up until how much? 18. Because we're talking about y-axis. Okay? So one more thing before we integrate. We need to write this in terms of y. Why am I doing this? Because it's a y-axis. Okay, so it's going to be y minus 2 over 4 root. Take the 2 here, divide by 4. It's going to be this. X is going to be equal to this. You need to make x alone. Once around the y-axis, x has to be alone. It needs to be in terms of y. Okay? So now can you integrate this? I'm pretty sure you can. Let me just make sure I'm doing this right. Okay, yeah, I'm doing it right. I just have trust issues with myself. I'm making too many mistakes today. Anyway, so now you can integrate. You have the bounds from 6 to 18. You have the curve in terms of y. So we can just apply the formula from 6 to 18. The curve, remember, squared, because your volume is squaring. Okay, so y minus 2 over 4 square root squared dy. Okay, so it's going to become pi 618 y minus 2 over 4 dy. I think you know how to integrate this. Okay, you have to split up the over 4. Okay, so it's going to be pi integral 618. Split up the over 4, so it's going to be y over 4 minus 2 over 4 dy. Okay, so it's going to be pi integral 618 y over 4 minus half dy. Now let's integrate, so it's going to be pi. Y over 4 will be y squared. There was already 1 over 4. Always when you have over denominator, take it to the side, then integrate. So 1 over 4 to the side, y squared over 2, and minus 1 over 2 y. Our bounds are 6 and 18. Continue. Simplify it a bit more. You're going to get y squared over 8 minus half y in between 6 and 18. So now substitute pi outside, 18 squared over 8 minus half times 18. minus open bracket 6 squared over 8 minus half times 6 close bracket. You should get 30. I got it here. 30. Okay, so 30 pi, obviously, with the pi. Diagram below shows parts of the curve y equals b over x, where b is a positive constant. If the volume obtained when the shaded region is revolved around the x-axis is 54 pi cubic units, then b equals 1. Okay, this looks easy. So they want you to find b. They want you to find the equation of hold on, let me. Yeah, okay. So the volume is equal to 54 pi. So integral a to b pi f of x squared is equal to 54 pi. Let's cancel pi with pi and start substituting. Okay, so we're going from what? From 1 to 3, right? So f of x squared, so b over x squared, dx, of course, is equal to 54. Okay, let's start fixing this up a bit. B over x squared is going to be b squared, so it's going to integrate b squared over x squared, right? You should distribute the square inside, equals 54. Now take the x up so we can integrate it. So we're going from 1 to 3, so it's going to be b squared x to the power of minus 2 dx is equal to 54. Continue your solving. So let's actually integrate integral of this. Take the b squared down, take the x down, add 1 to the power, divide by the new power, is equal to 54. Remember your bounds are 1 and 3. Continue. B squared, okay, you're going to have b squared over negative 1 x, because you took the x down, equals 54. Okay, so basically minus b squared over x is equal to 54. Okay, remember your bounds. Okay, your bounds are 1 and 3. Okay, 1 and 3. So we have to substitute and see it equal to 54. Let's substitute 3 first. So it's going to be, remember, we're substituting 3 into x, not into b. So minus b squared over 3. Now, minus, open your bracket, minus b squared over 1 is equal to what? 54. So you're going to get minus b squared over 3 plus b squared over 1 is equal to 54. Multiply by 3 up and down. So you're going to get minus b squared over 3 plus 3b squared over 3 is equal to 54. So you're going to get 2b squared over 3 is equal to 54. Multiply, cross multiply to get, multiply by 3. You're going to get 162. So 2b squared is equal to 162. Okay, and then you're going to get b squared is equal to 162 divided by 2, which is 81. So you're going to get b is equal to square root of 81, which is 9. Why didn't I take the negative square root? Because they said it's a positive constant. Okay, so the answer is 9. Thank you so much for watching. Good luck in your periodic final, whatever you're watching.